Okay, good afternoon. Now, as per the request from the student side, whatever yesterday I have taught, today again I will revise it within half an hour and then I will take next point. Therefore, yesterday we have seen first point, that is minimum number of teeth. Therefore, there is one standard formula to determine minimum number of teeth on spur gear. That is Z minimum is equal to 2 divided by sin square alpha, where alpha is nothing but pressure angle. There are, here it is given that three values of pressure angle, 14.5 degree and 20 degree. Therefore, 5 minimum number of teeth are required on the gear. The minimum number of teeth are required on the gear or pinion, whatever it is, to avoid the interference. Interference means what? Interference we have seen in previous lectures, that when the tip of one tooth will undercut the root of another gear tooth, at that time that tip of the tooth is going to remove the material, small amount of material from the mating gear tooth or the gear tooth which is in contact with that gear tooth. At that time what will happen? If you will remove the material from the base of that gear tooth, therefore that width of the gear tooth at the base will going to decrease. At that time what will happen? If suppose sudden impact load will be there, that gear tooth is going to break. Therefore, this minimum number of teeth on pinion, it is always required to avoid the interference, because in case of interference, since gear tooth we have considered it as cantilever beam, whose one end is fixed and other end is free, and at the free end that gear tooth force acts or tangential force acts, due to which gear rotates. Therefore, this is nothing but minimum number of teeth. Now next we have seen face width. Face width means what? I will show you in the figure. Okay, this length, total length is known as face width. Total length is known as face width. Again, I will show you. See that this total length of the gear tooth, the length of the gear tooth measured parallel to its axis is known as face width. Now, there are certain considerations that face width should not be too large, face width should not be too small. Therefore, optimum size of face width, we have to take it as 10 times module. Face width is denoted by letter B, and its proportion is it should be greater than equal to 8 times module and less than equal to 12 times module. Therefore, we have to take mid value, that is face width we have to consider, or we have to assume that it is 10 times module. Module means whatever that value is there, 3 mm, 4 mm. Therefore, in the design of gears, it is required to express the face width in terms of the module. In the Levy's equation, it is assumed that the tangential force PT is uniformly distributed over the entire face width. If the face width is too large, there is a possibility of concentration of load at one end of the gear tooth due to a number of factors like misalignment, elastic deformation of shafts, and warping of gear tooth. Therefore, if that load will concentrate due to these factors, what will happen? At one end of the gear tooth, the gear, that tip of the gear tooth at that end is going to break, because that whole load is concentrated at one point. On the other hand, gears with small face width have a poor capacity to resist shock and absorptions. That is, if that face width decreases like this, if the face width value will decrease less than 8 times module, at that time what will happen? That gear tooth is not eligible, or it will not absorb shock and vibrations due to the force transmission. At that time what will happen? Wear rate will be faster. For that gear tooth, wear rate will be faster, and a narrow face width results in a coarse pitch. Narrow face width results in a course pitch. Therefore, the optimum range of the face width is 8 times module less than B less than 12 times module. Therefore, in the preliminary stages of gear design, the face width is assumed as 10 times module. Therefore, always remember B you have to consider. B is nothing but face width. You have to consider it as 10 times module or 10 m. Next, we have seen hunting tooth. Hunting tooth, why? We have to consider the hunting tooth to distribute the wear uniformly over all the tooth, over all the teeth. Sorry. Therefore, you are knowing that in the example it has been given. Suppose ZP means number of teeth on pinion is equal to 20. ZG number of teeth on gear, that is larger gear, is 40. Therefore, what will happen? For every 2 revolutions of the pinion, the same pair of teeth will come in contact with each other. Therefore, every time when that same pair of teeth will come in contact with each other, there are chances that wear and tear of that gear teeth, means what is the two teeth we have to consider, will take place. And after some time, if these things is going to happen regularly, maybe after 2 years or 3 years, that both the gear teeth will break, or there are chances that fatigue crack is going to develop on the surface of the gear. And if that crack will grow and sudden impact force will act on the gear teeth, at that time that gear teeth or that gear tooth which is weaker or which is not having that much strength, that will break. Now, to avoid this, that is, if we have to distribute the wear phenomenon uniformly over all the teeth, then what we have to do? We have to increase one teeth on the gear wheel. Gear wheel means that bigger gear. Therefore, if now we will take ZP, that is number of teeth on pinion, is equal to 20, and ZG, number of teeth on gear, is equal to 41. Therefore, what will happen now? The pinion will rotate 41 times before the same pair of teeth will engage again. Therefore, what we have done? We have earlier that to one pair of teeth, they are coming in contact after 2 rotations. Now, in this case, that one pair of teeth will come in contact up. First, they will come in contact with each other, and after 41 times rotation of that pinion, they will come in contact with each other. Therefore, in earlier case, it was 2 times when that pinion will rotate. Now here, when pinion will rotate 41 times, then the same pair of teeth will engage again. Therefore, what we have done? We have distributed that wear phenomenon uniformly over all the teeth. Over all the teeth. Therefore, this extra tooth is called the hunting tooth. This extra tooth is called hunting tooth. It results in more uniform distribution of wear. It results in more uniform distribution of wear. Now, before this, I will show you the gear pair in contact with each other so that you will understand it better. I will show you some videos. 2 gears in contact. I will show you animation. Just check how the contact point is moving. This is the pressure line. See, this is the addendum circle, outside circle. This is the gear tip. This is the root circle or addendum circle. This is pitch circle. This is addendum circle. This height is addendum. The radial distance from pitch circle to the addendum circle is known as addendum. The radial distance from pitch circle to dedendum circle is dedendum. This much distance is dedendum. This is the tooth thickness. The thickness or the width of gear tooth measured around pitch circle is tooth thickness. This is circular pitch. The distance from a point on one tooth to the corresponding point on the next tooth measured around the pitch circle. This is the face width. You see that these two involved gears are there. Now you just see how two gears are in contact with each other. These two gears are external gears because teeth are in contact with each other externally. Now see that how the gear teeth are in contact with each other. See that how one gear rotates over another gear. This is the gear, this fixed gear, this gear is rotating. See that gear meshing animation. See that these two gears are there, how they are, these two gears are in contact with each other externally. Therefore, if this gear is rotating clockwise, this gear will rotate anti-clockwise. Like this motion of gears is there when they are in contact with each other. See that this will rotate clockwise, this is rotating anti-clockwise. Now I will show you interference. What is by interference? Then you will understand interference in gears animation. Okay. Now, what is an undercut or interference, that I will explain through this video. It is the process of removing material from the bottom of gear tooth to give more room for meshing gear. See that earlier our gear tooth was like this. After removing of the gear tooth material from the bottom, the gear tooth is becoming like this. See that. Therefore, gear tooth consists of two curves: involute curve, the tooth curve drawn from the base circle to addendum circle, base circle to addendum circle, and trochoid curve, the path of motion of rack cutter forming area. Therefore, what is an interference between gears? It is the unwanted phenomenon that takes place between two meshing gears when the top area of tooth of first gear comes in contact with any of the undesired areas of the second gear. The undesired areas of a gear that should not come in contact are tooth tip, tooth bottom. What are undesired and desired areas? A desired area for two gears to mesh on an involute gear is only area of the involute curve. See that this is the area of the involute curve. Means from this point to this point only, the contact point should be there. Undesired areas to root circle, then tip. See that this is the face of the gear tooth. Therefore, two gear teeth must be in contact only along the face only. Therefore, this is the flank. Face of the gear tooth is the desired area. Flank of the gear tooth is undesired area for contact point. Therefore, how to avoid interference between meshing gears? There are three methods. First is increase the center distance. O1, O2. O1 is the center of gear 1, O2 is the center of gear 2. Therefore, we have to pull these two gears away from each other. Okay, this is nothing but interference. Can you say? Okay, now see here. Now this tip of gear tooth is removing material from the flank of the gear tooth. See that this is the contact point. That's why this is known as undercutting. And because of undercutting, that tooth area at the base it decreases and tooth becomes weak. Gear tooth becomes weak. Therefore, this is gear terminology. This is center point. This is dedendum circle. The circle, this is the pitch circle. It is an imaginary circle. This green circle is pitch circle. Blue circle is base circle. What is an undercut? Undercut or intermediate is known as inter. See that this much portion, that blue portion is removed by tip of one gear tooth from another gear tooth. This much material is removed and that process is known as undercutting. That process is known as undercutting or interference. See that this much portion is removed. That's why this, always remember, desired contact area is known as face of the gear tooth. Face of the gear tooth means this much red line. This much is the desired contact area. See that this tip of the gear tooth goes inside the base circle. This is the tip of the gear tooth. It is going inside the base circle of another gear tooth. Actually, this tip should be above this base circle. Now, what will happen when this tip will enter inside the base circle? This tip is going to remove material every time from the root of that another gear tooth. See that. This is the face, this is the flank, involute curve. Desired area, undesired area. See that this is face, it is the desired contact area. See that desired contact area, and red, that is flank, it is undesired contact area. This is the top land. It is known as top surface of gear tooth. Therefore, this is nothing but interference. I think you have understood it. Now next is force analysis. Therefore, force analysis was seen. This is the gear wheel, which is the larger gear. Gear pinion. Always remember, pinion is smaller than the gear because pitch circle diameter of pinion is less than pitch circle diameter of gear wheel. This is the normal pressure line, Pn, along which this normal force Pn is acting. This pressure line is known as common normal, whereas this horizontal line passing through the pitch point, that is known as common tangent to the pitch circles at the point of contact. Point of contact is nothing but pitch point. Therefore, angle between common tangent and common normal is known as alpha. Alpha means pressure angle. Therefore, this normal force Pn is always acting along this pressure line. Now you can resolve this force Pn into two components, vertical and horizontal component. Vertical component is known as radial force or separating force. Horizontal component is known as tangential force. Because of tangential force only power is transmitted. Because of tangential force only torque or moment is generated. You can see here, this is the Pn. Now we have resolved this. PR is nothing but vertical force. It is known as radial force or separating force. It is acting vertically downward on this gear wheel and vertically upward on the pinion. Therefore, this is the horizontal force is nothing but tangential force or tangential component of load PT. This radial force, why it is known as separating force? Because this radial force, which is acting upward on the pinion, it will force the pinion in the upward direction, and the force, radial force, which is acting on in the downward direction on the gear wheel, it will force the gear wheel in the downward direction. Therefore, because of this radial force, the two gears will move away from each other, and that's why it is known as separating force also. It is known as separating force, and this is tangential force. This tangential force into radius of this gear wheel, it forms moment or torque, and because of this tangential force only, torque or power is transmitted from one gear to the other gear. Therefore, you can resolve this. Since this is the right angle triangle, you can resolve this and you can find out value of PT and PR in terms of PL. You can take angles sin alpha and cos alpha and you can find out. Now what is sin alpha here? Sin alpha is nothing but what? PR upon PN. Is it correct? Sin alpha is equal to PR upon PN. Therefore, PR is equal to PN sin alpha. And what is how to find out value of PT? You can take cos alpha. Cos alpha is equal to PT upon Pn. Therefore, PT is equal to Pn cos alpha. Or tan alpha is equal to PR divided by PT. Is it correct? Therefore, from this right angle triangle, you can find out the relation between PT, Pn and PR in terms of alpha. In terms of alpha is nothing but pressure angle. And alpha is nothing but pressure angle. And once you will find out PT, this PT into this radius of this gear is nothing but torque. Force into distance. PT is tangential force into this perpendicular distance is known as torque. and same formula is here. Pt into d by 2. D by 2 means काय? Radius, which is equal to mt. Mt means torque transmitted. Mt, this notation we are going to take throughout this subject. Mt is nothing but torque transmitted by the gears. And once you will find out mt, you can find out power transmission. Kilowatt is equal to 2 pi n into mt divided by 16 to 10 raised to 6. Directly you will get power in kilowatt. Is it? Now you have understood how the force analysis of the gear is there. And this already I have told. By using cos alpha and sin alpha relation, you can find out PR in terms of PT and PR. This, like this, you can determine. Now next is beam strength of gear tooth. Now already I have told to you that this gear tooth we have to consider it as cantilever beam. This gear tooth we have to consider it as cantilever beam whose one end is fixed at the base here and other end is free. And this tangential load is uniformly distributed over the entire face width. This distance is known as face width B. B is known as face width. Now this T is nothing but thickness of the gear tooth. T is nothing but thickness of gear tooth, and this is known as H, height of the gear tooth. This is known as height of the gear tooth is nothing but what? Addendum plus dedendum is nothing but height of the gear tooth. Therefore, what that Lewis has assumed, the analysis of bending stresses in gear tooth was done by Wilfred Lewis in his paper, The Investigation of the Strength of Gear Tooth, submitted at Engineers Club of Philadelphia in 1892. Even today, the Lewis equation is considered as the basic equation in the design of gears. Now, in the Lewis analysis, the gear tooth is treated as a cantilever beam. See that they have considered this as the cantilever beam, and the tangential component or the tangential force causes the bending moment about the base of the tooth. Tangential force causes the bending moment at the base of the tooth. That is when this tangential force will act. Because of this gear tooth will bend like this. Gear tooth will bend like this. Therefore, now what are the assumptions made while the derivation of this Lewis equation? First, the effect of radial force is neglected, which induces compressive stresses. Then it is considered that, or it is assumed that tangential force or tangential component PT is uniformly distributed over the entire face width of the gear. Third is the effect of stress concentration is neglected. Fourth is it is assumed that at any time only one pair of teeth is in contact and takes the entire load. Therefore, these are the assumptions. Now, same gear tooth is there. See that this is the tangential force PT. It is acting at a height h from the base. This is the radial force PR. This is the thickness T. This is the cross section XS, XX. Therefore, at the section XX, bending moment MB is equal to what? PT into H. At the section XX, MB is equal to bending moment MB is equal to PT into H. Now we can find out this. Since cross section at XX is nothing but a rectangular section of width T and or length is equal to T and breadth is equal to B. Is it correct? The rectangle section ची length आपण काय consider केली? T. Breadth काय आहे? B. But तुम्हाला माहिती आहे, you are knowing how to find out moment of inertia about neutral axis. BT cube by 12. Since why it is called as BT cube by 12? This moment of inertia we have found out across this YY axis. This moment of inertia is IYY. लक्षात घ्या. IXX असती तर काय झाले असते? TB cube by 12. आय एक्स एक्स म्हणजे काय, हॉरिझॉन्टल ऍक्सिस. ही मोमेंट ऑफ इनर्शिया कुठल्या ऍक्सिस भोवती घेतली आपण, व्हर्टिकल ऍक्सिस भोवती घेतली. त्याच्यामुळं मोमेंट ऑफ इनर्शिया काय आलेली इथं, बीटी क्यूब बाय 12. आणि वाय ची व्हॅल्यू काय येणार मग इथं, t/2. वाय ची व्हॅल्यू काय आली इथं, t/2. जर अबाउट एक्स घ्यायची असती तर इथं वाय ची व्हॅल्यू काय असते, b/2. वाय ची व्हॅल्यू काय आली असते, b/2. Therefore, this moment of inertia is along vertical axis. Value of y is also along vertical axis, and we are knowing the bending equation. mb upon I is equal to sigma b upon y. This bending equation you have studied in second year. Therefore, sigma b, that is nothing but bending stress, is equal to mby divided by I. Therefore, substitute all the three values in this equation. Sigma b is equal to pt into h into t/2 divided by bt cube by 12. Therefore, rearranging the terms, you are getting the equation pt is equal to b sigma b into t squared divided by 6h. Now what they have done, they have multiplied by module m to the numerator and to the denominator, so that this equation will remain same. Therefore, mb sigma b divided into t squared divided by 6hm. Now they have considered a factor y. Y is nothing but t squared divided by 6hm. Therefore, you are getting final expression pt, or tangential force, is equal to mb sigma b into y. And this y is known as Lewis form factor. Y is known as Lewis form factor. Therefore, what will happen? This, when the tangential force is increased, the stress also increases. Which stress? Bending stress. When the stress reaches the permissible magnitude of bending stress, the corresponding force Pt is called beam stress. That is when that stress will reach the permissible magnitude or maximum magnitude of the tangential force, then that strength is called as beam strength. Why it is called as beam strength? Because we have considered gear tooth as a cantilever beam. We have considered gear tooth as a cantilever beam. Therefore, that strength of the gear tooth is we have considered as the beam strength. Therefore, beam strength SB is nothing but what? It is the maximum value of the tangential force that the gear tooth can transmit without bending failure. This is the definition of beam strength. It is nothing but what? Maximum value that the gear tooth can transmit without bending failure. Therefore, replacing SB by PT, therefore, or PT by SB, SB is equal to what will be our formula? MB sigma B into Y. Therefore, this is known as Lewis equation. This is known as Lewis equation or beam strength equation, where SB is equal to PT. Load, what is the unit of load? Unit of load is Newton. Therefore, beam strength of SB is nothing but beam strength of gear tooth in Newton. Sigma B, permissible bending stress, Newton per mm square. Module M, it is in mm. Similarly, this B phase width is nothing but mm. This Y is nothing but Lewis form factor. It is unitless quantity. Y is nothing but Lewis form factor. It is unitless quantity. Always remember. Therefore, this equation is known as Lewis equation. Now, there are different values of Y depending upon the number of teeth. Depending on the number of teeth. Here, this table consists of mainly two columns, Z and Y. Therefore, for 20 number of teeth, Y value of Y is 0.320. For 40 number of teeth, 0.389. For 70 number of teeth, 0.429. For 90 number of teeth, 0.442. For 32 number of teeth, 0.364. Therefore, this table indicates value of the Y for different number of teeth for 20-degree full depth in olive system. Means if the pressure angle is 20 degree, and if there are this Z is nothing but number of teeth on the gear or pinion, and corresponding value of Y are there in the table. I think you have understood it now, or not? Therefore, in order to avoid breakage of the gear tooth, due to bending, the beam strength should be more than the effective force between the meshing teeth. Therefore, SB should be greater than P effective. In the design of gears, it is required to decide the weaker between the pinion and gear. Therefore, you are knowing that SB is equal to MB sigma B into Y. This is the Lewis equation. Now, how to decide weaker? Now, always remember, when two gears are in contact with each other, the material of the two gears may be same or may be different. The material of the two gears may be same or may be different. Now, when the pinion material and gear material, pinion is smaller gear and gear or wheel is nothing but larger gear. When the material of both the gears is same, at that time we have to consider that pinion is weaker than the gear. Pinion is weaker than the gear. But when the material of the two gears is different, that is, pinion is made up of steel material, gear is made up of cast iron material. At that time, we have to find out which gear is weaker, either pinion or wheel. At that time, we have to do this calculation sigma B into Y. Sigma B into Y, this product we have to find out for both pinion, that is for steel material, and sigma B into Y for cast iron material. And which value is less? Sigma B into Y, that product, whose product is less for the pinion or gear. That gear or that pinion we have to consider it as weaker. And we have to design the gears according to that, either pinion or either gear. We have to design gear म्हणजे काय? We have design of gears means we have to determine module. We have to determine module of the gear. Once you will determine module, you can find out face width. Face width B is equal to 10 times module. You can find out addendum, you can find out dedendum. There are standard proportions of gear tooth. Therefore, just you have to insert value of M. We have seen the standard proportions of gear tooth. See that these are the standard proportions of gear tooth. Once you will determine M, see that these are the standard proportion. Addendum is equal to module. Once you will determine module, now here addendum is equal to M means addendum is equal to module. Dedendum is 1.157 M. Just you have to submit, multiply this 1.157 into M. You will get dedendum. Is it correct? Now what is pitch circle diameter formula? Pitch circle diameter formula is equal to D is equal to M into T. M into Z or M into T. M into Z we will take. Z means number of teeth. Therefore, once you will determine module, number of teeth are available given in the problem. Suppose 20 number of teeth, 20 into you have found out 4 module. Module value of module is 4, means 20 into 4 this 80 mm is nothing but pitch circle diameter of pinion. Similarly, you can find out pitch circle diameter of the wheel, M into ZG. Means like this, once you will determine the module by using these standard proportions. See that these are the first stub tooth. Addendum is 0.8 times module, dedendum is equal to module. Therefore, these standard proportions are available. Once you will determine the module, you can find out all the values. Therefore, that is known as design of the gears. That is known as design of the gears means what? We have to find out dimensions of the gear. We have to find out dimensions of the gear. And to find out dimensions of the gear, first we have to determine module of the gear. Because always remember, while designing the gear, you have to select module first of all, and then we have to find out the dimension, and then we can manufacture the gear. Remember, first of all, module is selected. I think this Lewis equation you have understood. Understood or not? Lewis equation. I think now 2 o'clock is there. We will stop here. Please don't leave. I have to take your attendance.
ठीक है